Imagine digging up a treasure chest deep in the ground. And when you open it, it's not filled with gold or jewels, but with dust, bubbles, and pollen. Well, that is exactly what an ice core is. It's Earth's frozen treasure chest. Ice cores hold important information about Earth's past, like temperature, precipitation, things about the atmosphere, volcanic activity, and wind patterns. Scientists find out this information by drilling deep into the ground and extracting an ice core. Then they take that ice core into a lab and melt or crush bit by bit to see what lies in it. Scientists might find things like bubbles that can tell you what the air was like back during the time. They might find dust, ash, or dirt from volcanoes or deserts, which could show what the volcanic activity was back then. Scientists could also find things like microorganisms that could show what kind of life existed back then, or even what the environment was like during that time. To understand all this new information better, I created a 3D model and 3D printed it to help show how scientists would get this information from the ice cores. So I created this model to have many layers to symbolize the many layers that ice cores have. The layers can be used to show many things about the time, such as the thickness of a layer provides clues about the precipitation. A thick layer means that there was greater snowfall during that time. Layers in ice cores provide a record of years and seasons. Going back to the bubbles in ice cores are preserved gases that were in the air at the time. For example, one of these gases could be CO2, which could tell many things. One of those things is about the temperature. Lower CO2 means the temperature was colder, and higher CO2 means that the temperature was higher. This is because CO2 is a greenhouse gas, which means it traps heat in Earth's atmosphere. If we saw ash, we can assume that there was a volcanic eruption or some sort of volcanic activity during that time. The layers of an ice core are like timestamps. The farther layers to the bottom means the older the layers are. The younger layers are closer to the top. One scenario that could happen is scientists having two ice cores, both from 12,000 years ago when one of the ice ages was ending. Scientists could have one ice core from Antarctica and the other one from Greenland that could tell many things about the changes those places had during the transition from the ice age. A transition that started happening was both places getting hotter and a rise in CO2. In the ice core, this will be shown as bubbles with gas in them. The Antarctica CO2 levels would have risen slowly, but the Greenland ice cores would have shown the CO2 levels rising faster. This is because warm water from different bodies of water brought warm water towards Greenland. When Earth's temperature started rising, these currents carried heat north, melting Greenland's ice fast. On the other hand, Antarctica is surrounded by the super cold Southern Ocean, which kept it colder for longer. Another reason for Greenland heating up faster is the Milankovitch cycles, which we learned about in class. Because of Earth's tilt and orbit around the sun, the northern hemisphere got more sunlight at the end of the ice age. That meant Greenland, because it's in the northern hemisphere, got the heat first, while Antarctica in the southern was behind and didn't start heating up yet. The pollen in Antarctica ice core is basically non-existent because there are little to no plants in Antarctica. But in the Greenland ice core, you can find out that there was a pollen increase because of the forest growing back. When the ice age ended, all the life was returning to Greenland because of the warmer climate. The microorganisms in Antarctica's ice core would be frozen and ancient because Antarctica is really cold and all the organisms would stay frozen. But in the Greenland ice core, it would show that the microorganisms would start reappearing again because life was beginning to come back. This is a few of the many things that could be figured out through ice cores. There is still more to figure out about Earth's past. To conclude, if you ever see an ice popsicle in Antarctica, don't lick it because it could be full of ash, dust, bubbles, and microorganisms.